having some series of fundamental basic principles in algebra and mathematics that is suitable, and it is very, very important for scientists, engineers, generally. Basic mathematics that has to do with addition, equations, logarithms, and so on and so forth. So we have just some few problems here. I promised in the last video that we're going to be talking about problems. We're going to solve one or two problems so that we can apply all those rules and all those principles we have discussed earlier. So we have the first problem here. We have 1 over 3 log 27 is equals to log 10a. Of course, it's obvious that we have to find everything is evident except a. So we are going to find the value of a from the video. Here we have a quotient of two funny looking logarithmic expression, and of course this we are not to solve, we are to simplify this to make it more compact and more presentable. And then for this it's obvious that we have to find the unknown, which is x, so we have to find the value of x. It is obvious that all this we need to apply the logarithm, and we can apply the logarithm to base 10 since we know the log of 2 and the log of 3. Alright, so so all this we believe they are common logarithms. We believe they are common logarithms. Earlier on I said that common logarithms are logarithms to base 10, and logarithms to base e, which is 2.7182, are an Napierian logarithm or the hyperbolic logarithm. So please let's take a look at that. This is 1 over 3 log 27, and that is equals to log 10e. Log 10e. So from here we know that we can simply write this as 1 over 3 log 27. 27 can also be written as 3 raised to the power of 3. Because 3 times 3 is 9, 9 times 3 is 27. So we can write this as 3 raised to the power of 3. So this is this, and here we can apply the law of logarithm that says that if these are multiples, then we can write it as an addition, as a sum. So this can be written as log 10 plus log a. So remember that rule. Remember the rule. This is 10a, this is 10 times a. So we can split this in sum as log 10 plus log a. So you remember the laws of logarithm we discussed in the last video, where we can simply bring the power over here. So we can simply multiply the logarithm by the power. There was a proof to that. So we can have this 3 times 1 over 3 log 3. So we can actually bring this over here, and we have that. And this is log 10 to base 10. This is actually 1. And we have log a, right? So this we have a cancellation of this, and we are left with log 3 minus log 10. How did I get this from here? I did that by subtracting. Subtract log 10 from both sides. From both sides. So that is what I did. I have my log 3. That is the leftover right here. And I subtract log 10 from both sides. From both sides. So I'm going to have this off from here, and I'm going to be having minus log 10 over here. And here I have log a. Here I have log a. We are closer to our answer. Here, we can simply apply the second rule that I discussed on logarithm. We can apply the second rule. And the second rule simply says that this is going to be log 3 over 10. So log 3 minus log 10, by that rule, is going to be log 3 over 10, and we have log a. And there is a rule that says, we have a rule that says that if log n is equals to log n, if log m is equals to log n, and they have the same base, then m is equals to n. Beautiful principle. So if you have log m, like log Mason or log Miriam is equals to log Nicholas. Log Miriam is equals to log Nicholas, and they have the same base, then Miriam is equals to Nicholas. That's what the law says. And like that is true, and we apply it right here, we have our answer to be equals to 3 over 10 will be left here, and a will be left here. That is our answer. Our answer is simply 0.3. So that is all for that particular question. Let's go over to this. I would love to use that. Okay, I would love to take this out. So you can always take back the video and go back to get those points clearly. The next video, the next question here, which is actually an expression. We can apply this first rule here, but to do that, we can have log 9 minus log 3. Let's work on this. This we know can be 1 over 2 log 81 is 9 to the power of 2. 9 to the power of 2. But I will advise us to use 81 as 3 raised to the power of 4. From my first video, that is actually well interpreted. This can be divided by 2 log 3. So if I interpreted 81 as 3 raised to the power of 4, I can also write 9 as 3 raised to the power of 2. So let's see how we can do that. So I can have this as 3 raised to the power of 2 minus log 3. And I'm going to use the reverse of this rule. Remember in the last video we said log a raised to the power of c is equal to log this. So, but I'm going to go this other way. So we agree that this is equals to this, but I'm going this other way, the opposite way. So for this, I'm going to be having, that will be plus log 3 raised to the power of 4 and to the power of half. So please take note of that. So I'm taking this power, so I'm taking this coefficient here to be the power here, just like taking the coefficient here to be the power here to have this. So if you have any challenge, you can always think about this. So please, I can do some math here also. I can also apply that here to have this same principle, which I know you're thinking of here, to give you that. So I think you're cool. Alright, so applying the laws of logarithms can also have this. You remember that this is log 3 raised to the power of 2 divided by 3. So please take note by the first law times 3 raised to the power of 4 times half. Please, we can solve this as 4 times 1 over 2 is simply 2. Simply 2. So this is 2. So this is log 3 raised to the power of 2. So please take note of what I did here. It's like having log A minus log B plus log C. So we are going to divide A over B and we multiply by C. So that is what I have done. Yes, still the same thought to this. So we can apply some indices right here. We have 3 raised to the power of 2 times 3 raised to the power of 2 divided by 3. This is going to give us 3 raised to the power of 4. So we add the powers from our first video. You can always check out the first video. And this is divided by 3. We also agreed that we can subtract these powers to have this. So take note of the first video, that is what we did. So this is going to give us log 3 raised to the power of 3, right here we have log 3 raised to the power of 2. We are close to the end of the video, so we have to take this up. We are close to, so what we have is log 3 raised to the power of 3 and log 3 raised to the power of 2, which we can also still use this principle again. Still use this principle and have 3 log 3 divided by 2 log 2. I'm sorry, 3. So we can do a cancellation for which we have our answer to be 3 over 2. So our answer is 3 over 2. So that's the answer to it. And that's very interesting that the whole of this thing is actually equal to 3 over 2. Still there is another substitute method that can be faster from here. The next method that can be faster will be log, this can be log 3 raised to the power of 2, this is log 3, this is 1 over 2 log 3 to the power of 4 over 2 log 3, and that can give us 2 log 3 minus log 3 plus 4 times 1 over 2 from here will give us 4 over 2, which is 2 log 3 over 2 log 3. So by collection of like terms, these are like terms, log 3, this is log 3, this is log 3, they are like terms. So we can just say 2 minus 1, that is 1 plus 2, that will be 3 log 3 over 2 log 3. So that's collection of like terms. For those of you who have challenges here, it's just like saying 2 cakes minus 1 cake plus 2 cakes. So it's like this is 2 cakes minus 1 cake, that is 1 cake plus 2 cakes, that will give 3 cakes. So that's what you have here, simple as that. And you have that. So this can cancel this and you have the answer to be 3 over 2. So which method you like, you can apply this method, you can also apply this method to have an answer. So I round up the video by tackling the last problem. So you can always pause the video and check out the solutions. The last problem here, we have 2 raised to the power of x minus 1, and that is equal to 3 raised to the power of 2x minus 1. So we cannot use the principle where we reduce this and cancel out the bases here because of the bases are not similar. The bases are not similar. So what we do is to apply logarithms to both sides. So we have log 2 raised to the power of x minus 1 equals to log 3 raised to the power of 2x minus 1. So the essence of logarithm is to solve exponential problems like this. When we have powers that are unknown, we call them exponential problems, exponential equations. So from this, again, we are going to be having x minus 1. I'm advising to put that in a bracket. Then we have 2, and here we have log 3. Sorry, I can call this 2x minus 1 in a bracket. So I have x minus 1 log 2, and that is equals to 2x minus 1 and log 3. So from your table, you can check your logarithm table. Log 2 is the same thing as 0.3010, and log 3 from your table is 0.4771 from the table. They are closer to the solution. Yeah. So this, we can open the brackets and have this x minus 0.3010. This time this will give us 2 into 0.4771. So we get x and minus 0.4771. So we can collect like terms to have 0.3010x minus 2 into 0.4771x equals to minus 0.4771 plus 0.301. So I would not want to go further here. Here you can simply multiply this times this. You have a calculator, you can always do that. 2 times this is going to give you 2, 4, 5, 9, and 0. 2 times will give you that. We have x here. We have 0.3010x. So we can subtract that 0.9542 minus 0.3010. That is going to give us 2356. So here we have minus 0.6532x equals to, so here we also have 4771, 0.3010, and that is 1, that is 6, this is 7, and this is 1. So we have here minus 0.1761. I'm sorry I'm not using the calculator. You can use the calculator and confirm all these 1761, this cancel this, and you have your x. You can take this up. So you have your x to be 0.1761 divided by 0.6532. So you can divide that and have your answer with your calculator. So that is just the application of everything we've been discussing in the first 8 to 7 videos. You can solve a lot of problems. You can send problems over to my email and we can work it out together. Thank you and bye.